Hello and welcome. My name is Renan Ribeiro. I'm a doctoral candidate at the University of Minho, and in this video, I will very briefly present my doctoral research with you. Hope you enjoy it. So let me kick things off by stating the objective of the research. In a nutshell, this is essentially an experimental work that explores the use of a class of tests, here referred to as vibration-based tests, to characterize the viscoelastic properties of cement-based materials. The key point here is to perceive how we may shift the perspective of a viscoelastic testing from traditional static tests to vibration-based tests, which has been done in other fields, but is still not used or common, at least quantitatively, in civil engineering. Cracking the nutshell open, we specifically aim to first develop a reliable test method, then produce quantitative data equivalent to traditional methods, and once we hold a grip on all of that, explore what novel information they can provide regarding the viscoelastic behavior of cementitious materials. Traditional static tests consist of applying a load with a step function and monitoring the deformation of a specimen over time, which gives the material compliance function. The way usual setups are deployed lead to many experimental weaknesses, some of them listed here. Vibration-based tests measure viscoelastic constitutive parameters in a totally different approach. These tests involve applying a dynamic harmonic load, which may be torsion, bending, tension, or any other type of effort, to a sample and measuring the phase shift and peak difference between the load history and the sample response. Some weaknesses typical of static tests are then avoided, and among our other strengths, the easiness with which temperature is controlled during a vibration-based test may allow to explore the concept of accelerated creep tests in cementitious materials, which is yet to be fully understood and validated and may constitute a big experimental advance. Concerning the methodology, this research is built around three main experimental tests: static creep tests, which will produce our gold standard data; vibration-based tests, which have a central role in this research and will be performed with dynamic shear rail meters and DMTA machines; and with a support actor role here, the EMM arm test, which will help to uncouple the solidification and viscoelasticity process when we tackle the early age period of cementitious materials. And now, lastly, maybe you are wondering where is the digitalization in all of this, since this is the main theme of the cluster I'm part of. Actually, as this is essentially a development research, big part of my work is actually finding solutions to experimental issues for which no solution is reported in the literature. And this is done mainly within a digitalization frame. This involves several development activities such as digital fabrication, programming custom software for data processing and exploration, and development of custom-made cyber-physical systems to either automate tasks or produce data in the precise way we want. So this was a brief presentation of my doctoral research. I hope you enjoy it, and I'll be most pleased to take on any questions you may have during the next chatting sessions. Thank you.